everybody who is watching this fantastic video. I'm very happy to have you, and I'd like to take this opportunity to welcome you into this fantastic program where we are training and incubating our beloved students who are very interested in mathematics and science. So my name is Olenjolai, Moko TAYAI. Just call me Olenjolai. I'm a teacher and also an electronics and telecommunication engineer. But also I'm a national teacher. I'm teaching the national level, and I have a responsibility to take care and even to teach and train ordinary secondary education students of the present and future generations. I'm a Tanzanian, and I'm conducting these programs on the focus of the syllabus of United Republic of Tanzania. So I'd like to welcome every foreigner. So before even I go into details of today's session, which is session 4, I'd like to take this opportunity to welcome everybody who is watching this video into one of our online schools that called Tanzania Online Ordinary Secondary School in square bracket Olenjolai. This is an online school. It's not a physical school. You enjoy all of these contents, all of the trainings. Just we meet online. It means we meet by the power or by the connections of the internet. Simultaneously, let's welcome you because we'll be sharing these contents in the international platforms so that every students can access it at any time. One of our official YouTube channel that's called Tanzania Online O-Level Safety School in square bracket Olenjolai. So, thank you for being a part of Tanzania Online Ordinary Secondary School in square bracket Olenjolai. I know one of the questions that comes in your mind: what are we doing? What problem are we solving? And why do we need Tanzania Online Ordinary Secondary School in square bracket Olenjolai? That's the very important questions. And I would like just to answer you quickly, and then we'll go into today's session. The theme, mean that the purpose of Tanzania Online Ordinary Secondary School in square bracket Olenjolai is to train and teach some group of students who will be ready to extract knowledge and wisdom from science subjects and the mathematics in order to combine with the knowledge, understanding, and the wisdom that will be extracted from the Word of God written in the Holy Bible in order to solve real life problems. So the main objective of TAYAI, it is abbreviations of Tanzania Online Ordinary Secondary School in square bracket Olenjolai, is to teach you on how you have to think outside of the class. First of all, to understand the classroom instructions, to understand the instructions written in the Word of God. Secondly, how you can extract knowledge, understanding, and wisdom. And then how you can apply in order to solve real life problems. So it's a lifetime programs actual. However, that will be focusing on the classroom instruction first in order for your mind to be in peace, because I know that you are fearful on failure of the exams. So that's what we are doing actual. We'll be focusing on extracting knowledge, understanding, and wisdom in two aspects: in classroom instructions, in mathematics and the science subjects, and also extracting knowledge, understanding, and wisdom in perspectives of the whole Bible, in order and then combine these two knowledge, understandings, and wisdoms in order to solve real life problems. So that's what we are going to do, and that is our main focus. So stay tuned, stay connected. Our classes are very interactive, so you can use the comment section right now. Later on, we'll be releasing another platforms which can allow you to interact more and even to send your homework which has been written, so you can just take a photo of it and then send to me in order to review your work. But right now, you can use the comment sections in order to ask you questions, just to give me the feedback whether you understand what am I going to teach you, and etc. And even anything else that you want to share with us, which can build up the life of somebody. So I know that possibly you're students who's watching this program, you're warmly welcome, possibly a parent or a sponsor, or maybe a guardian of a particular student. In this channel, we are teaching, or in this online school, we are teaching all about ordinary education. That's the area of our specialization. So we'll be collecting and just having and recording the active lecture or the active session or the active period, just like the normal sessions that we used to conduct, but will be just teaching in a very different way, in a very simplified way, and even in a very entertaining way, because science subjects and mathematics are the beautiful subjects for the rest of your life. Again, so before I take you into the today's sessions, I would like just to let you know about registrations. Just registrations. How can you register yourself into OSO? Why should you register? Because in any physical schools that you went, the first day you spend possibly to be registered, to be registered into the particular schools that you are studying right now, or even before you get transferred. So the good thing you used to do in physical school, you used to do registrations after every term, so after 6 months. The good thing or the good news that you just have to do lifetime registrations into OSO only once. So you do just once registrations, it will be permanent registrations. You don't need again to do registration, such kind of registrations, but it is very important for you to be a part of OSO. So the first step, if you don't have an email or you don't know what the meanings of email, then you can create or open either a Gmail or Yahoo Mail online. Just go to the Google and then write, how can I create a new Yahoo Mail or a new Gmail? The second step, when you have your email, then you can skip step 1. Step 2, sign in YouTube by your email. Means when you sign in, it means that the YouTube platforms will ask you about username and password. The second step, search also. Don't try this word in because you're in Google, but the thing that they want to ask you that write this sentence, okay, this phrase, Tanzania Online O-Level Secondary School in square bracket Olenjolai, and then you'll see the icon of the school. So click that icons and then it will take you into our Tanzania Online Ordinary Secondary School in square bracket Olenjolai. So once you click it, then you'll see something video. Okay, you'll see first of all home video, then you'll see a playlist, you'll see community, you'll see channel, it means that associate related channel, and you'll see about. So this playlist is very important because all the subjects we used to collect the related sessions of a topic and create something called the playlist. So, or you can scroll down, just scroll down, so you'll see some of the playlists that we've been given some options to give them the priority. But make sure that you use playlisting, and also you scroll down in order to see the playlist, the collections of sessions of web. For example, in web, this is it's a 50 session. So we have session 00, we have session 00, the general introductions of physics from 1 through from 4. And then you have session 1, session 2, session 3, and this is session 4. So you have to go through the previous sessions before you just come into this before you come to session 4. We have departments. We have more than 4 departments. We have departments of physics, departments of chemistry, departments of basic mathematics, and departments of 40 of kingdom of heaven, right? So every department has a subject. For departments of physics, we are teaching you 4 subjects: physics form 1, physics form 2, physics form 3, physics form 4. And then the subject of the day is physics for the pre-form 4 or form 4 students. And then we are in chapter 1 that's called waves, and this is session 4, solving problems of 40 of waves. Waves parameter. It means the solving problems of parameters of waves. Some parameters of 40 of waves. So that's the subtitle or the objective of the today's session. So I know that, according to my research, I know that many students, when they get into, after they pass the Form 2 exams in Tanzania, after they pass the Form 2 exams, they have an options to be either to be pure artistic students or pure business students or pure science students. Many students, I know, they opt to business studies and even artistic studies. Why? Because they have been discouraged with the way they used to be taught in physics. The good news, this now is not limited. There's not a physical meeting between a teacher, between Olenjolai and the students. So you can take this advantage wherever that you are, even you are in Wadi school, we call it Shule za Kata in Swahili. So you can take advantage of these programs, and hence I believe that you are going to do very well in physics and will love it more than you think, more than even other subjects. So before I go, I will give you some of the couples of announcement later. Let us start on today's session. So we say that the subject is physics. So let me do the quick review of what we taught you. Quick review of session 3. Be serious, please. Session 3. So in session 3, we have been teaching about it. It has been titled as parameters of waves. So we have discussed so many parameters of waves. I've taught you about amplitude. Okay, I've taught you about amplitude. I've taught you about parameter that we call the cresting. Okay, cresting. I've taught you about another parameter which we call the trough. Say trough. I've taught you about another parameter which we call the frequency of the wave. I've taught you another parameter that we call the period. Okay, period of the wave. And then I've taught you another parameter that we call the wave velocity or velocity of wave. So I taught you almost 630 parameters which are very important. Okay? And then we say that the wave can be represented as sinusoidal. Okay? The waves can be represented as sinusoidal. This is displacement. This is displacement axis. And this is time axis. So with this sinusoidal, we say that we can have, this is just a sketch, can have a wave trajectory of this form. Okay? So this is the wave trajectory of this form. So this wave trajectory, we say that this is a distance. So here we have what? So this is what you call the period. Period is the time taken for a wave to complete one oscillation. The time taken for a wave to complete one oscillation. And then we say that this is periods, but also we define that that's also it's the wavelengths. Okay? Because we define that that is wavelengths. Friends, also that we have a wavelength there, we have a trough, we have a wavelength. Okay? So this is against the distance between, so wavelengths, we say it's a distance between two successful trough or successful cresting. So this one, it's the one that we call crest, and this one, it's the one that we call trough. Okay? And then this is period, this is wavelength, so velocity is a relationship now. So you have to remember this wave profile. So let us begin with correction. Correction of what? Of homework 3, which was example 1. The question stated that deduce the relationship between frequency, velocity, and the wavelengths. That the questions I left to you. Did you do it? Okay, so if you've done it, let us do correction. So solution. So to deduce the relationship, we say that the first step, I mean that in the mechanical motion or in motion, we used to say that when we have 3 physical quantities, time, distance, and velocity, then velocity will be dependent variable, while distance and time will be independent variable, right? So the first step, we say that we call general form of what? Of velocity. Velocity of a body. So here we have velocity, and this is equal to distance of what? Over time. So in case of wave, so the second step, the distance of a wave, is called what? Is wavelength. And the symbol for the wavelength is lambda. Okay? Please copy these instructions for you to be registered permanently. Why should you subscribe? That's very, important questions. When you click this button, so after you search the to also click these buttons, and then this button will be changing into the subscribed. And afterward, click the icons of share in order for you to share the link of this video with your friends through WhatsApp, through Instagram, through Twitter, through Telegram, through Facebook, and through TikTok. Any social media you can share the link to any students in Kagera, in Rukwa, in Ruvuma, in Songea, in Twara, South Africa, in Cameroon. So you can share these contents with them through the social media so they can go and take advantage of it. So please pause the video and then just copy the instructions for you to be registered permanently, because you'll get notification. Why should you subscribe onto Tanzania Online O-Level State School in square bracket Olenjolai? The aim is we are planning to record more than 400 videos of ordinary basic mathematics, physics Form 1 to Form 4, basic mathematics Form 1 to Form 4, and the chemistry Form 1 to Form 4. So for you to get notification from the YouTube, we really ask you that to subscribe in order to get notification once we add a new video. For example, now after session 4, we'll record session 5, session 6, session 7, session 8, session 9, session 10 of WAVE. So we still have so many sessions that will be on the way. So for you to get notifications whenever we add a new video, please subscribe. And as YouTube community will give you notification whenever that you are online. Okay. So we say that enjoy the beauty of physics, please. The distance of the wave is wavelengths. And then the time taken by the wave to complete one cycle. This we call in physics is called your period. Period, and the symbol is capital T. So for that case now, means distance, the distance there in this formula, so suppose that this is equation 1, this will be replaced by what? Wavelengths, and then time, which is T, small t, this will be represented by what? By period. So therefore, and this velocity now we call it the wave velocity. The wave velocity will be equal to what now? Will be equal to wavelengths, say wavelengths, which is lambda over what? Over period. Okay, over period, which is t. All right. So if that the case, we say that this is wave velocity. Okay, this is wave velocity, and this is equal to what? Wavelengths over period t. So this will be the second equation, right? And then as we go for the steady state. Okay, the steady state, we say that you have to recall the relationship between frequency and period. We say frequency is equal to reciprocal of 40 of period. So it's 1 over t. So for that case now, this will be equation 3. So we say that substitute equation 3 in what? In equation 2. Okay, in equation 2. Equation 2. So when you substitute that we have equations in equation 2. Okay, when you substitute, then we say that what? Wave velocity. Okay, wave velocity. This is equal to what? Is equal to wavelengths over period. So we say that this is wavelengths times 1 over period. And then we say that when you substitute, this is wavelengths times frequency. So wave velocity or wave equation. So wave velocity, which is V, is equal to what? Is equal to wavelengths times frequency. So this is very important formula for the rest of your life in ordinary education and even in advanced education, later on in ordinary diploma, and even at that graduate level. We used to start these formulas when we've been dealing with electromagnetic inductions or electromagnetisms, maybe in electrical engineering, maybe if you're doing mechanical engineering, you'll find this formula as long as you continue. So never lose it. Even if you pass the physics, the exam for the physics, then we will ask you that, or will tell you that you should remember this formula. So after even you graduate your certificate secondary education examination. So this is the wave velocity, so we call it the wave equation. So when you be asked maybe write wave equation, then it means that you have to write this equation, right? So wave equation, it means that wave velocity is equal to wavelength times frequency. So it means that also you can express this form, you can express the formula in other form. If you are looking for the wavelengths, you have to divide by frequency both sides. So this is the formula. Again, if you are looking when you're being given velocity and frequency, when you're being given velocity and wavelength, and then you're looking for frequency, then you take the velocity of a wavelength. So you have 3 formulas. 1, 2, 3. These are enough at this time. Remember that this was example 1. It's enough for this time for you to navigate and solve so many problems in wave. And today's session will be focusing on wave equations. Okay, solving problems of parameters of waves. Okay, so we say that the parameters of wave, or simply we call this session, we are dealing with wave equation. So this is called the wave equation. In brackets, we call it the wave equation. EQN is abbreviations of equation. So ladies and gentlemen, after doing the corrections of example 1, allow me right now to present example 2, which is computations, which is a computation question. So find the wavelength of the sound wave. Question state that find the wavelength. Tell your neighbor, do you love wavelengths? Do you like wavelengths? Find the wavelength of sound waves. Okay? Find the wavelength of sound waves, okay, of velocity. Of velocity 340 meters per second when the frequency is 1000 Hertz or 1 kilohertz. 1 kilohertz. Now the question, find the wavelength of the sound waves of the velocity 340 meters per second when the frequency is 1000 Hertz. Remember, Hertz is the SI unit of frequency. The SI unit of period is second. The SI unit of wavelength is meter. The SI unit of wave velocity is meter per second. Meter per second. So SI unit of wave velocity, you have to remember, is meter per second. Wonderful. So you have to find the length. So you have to follow the following step. The first step, tell your neighbor that you are doing the first step. Do you love physics? Please tell me in the comment section. Do you love physics? Do you have purpose in physics? Do you have a vision which really need the knowledge of physics? If you do have, stay tuned. I believe that I will transform you radically from one point to another point, and you'll never forget, because physics is a beautiful subject and it's a very interesting subject. Okay? So the first step, data given. Let's enjoy the computations in physics. Data given. That's the first step. Data given, what are the data that have been given in these questions? The first data is velocity. And this velocity is velocity of of the wave, v. We have been given velocity of the sound wave is 340 meters per second. The second data that we have been given is frequency. So frequency is f. Okay. So here we have been given frequency of the wave is 1000 Hertz. Okay. So then again, so we've been asked to find out the wavelengths. Wavelengths, which is lambda. This is this is required. Okay, required. So the second step, say that we call what? We call the wave equation, or the formula of wave velocity equation. Wave velocity formula or equation, whether you call it the formula or equation. Okay? How does it state? I told you today that velocity, which is v, is equal to wavelength times frequency. So what are we looking for? So if velocity is equal to wavelength times frequency. So this is equation 1. Okay? Wonderful. So equation 1, so you have to go for the steady state. That's a general wave equation. What we have been asked, we'll be given velocity, and we'll be given sorting frequency. What you have to find? Velocity. So ladies and gentlemen of the form 4 or pre-form 4, we got the steady state. The steady state, we say that let us make wavelengths the subject in equation 1 above. Okay, so we had velocity lowercase is equal to wavelength times frequency. So divide by frequency, divide by frequency. Wavelength is equal to velocity over frequency, right? So if that's the case, we say that wonderful. So wavelength is equal to what? Velocity is 340 meter per second over frequency. Frequency is what? 1000 hertz. Okay. So you have to be careful on the SI unit. So you can simplify 0 and 0, and then you remain with what? You have 34 divided by 100. Then you have what? Meter over second, and then hertz is 1 over second. Right? So ladies and gentlemen, 34 over 100 is not possible, so we add 0. Then we have, so no, it's not possible. 34 over 100 is equal to 0. It's not possible. It means that 34 is less than 100, so we write 0. 20, and then we add 0. Then 340 over 100, we get 3 with the remainder of 40. When we add another 0, 400 over 100, we get 4. So then in case of the unit, we have meter per second, and then say 40 times 40, second over 1. So second and second cancel. So simply this is 0.34 meter. So therefore, ladies and gentlemen, we say the wavelength of sound wave, the wavelength of what? Of sound wave. The wavelength of sound wave is what? Is 0.34 meter. Okay, that's the response. Wonderful. I believe that you've enjoyed. Let me take you into the example, because I think that now my students are saying, sir, give more, give more, give more, give more, give more, give more, give more. Teach us more, teach us. Okay, and then I know my students are saying that, thank you, sir, because thank you, sir, for revealing this secret. Wonderful. So then we have a library. Before even I give you this question, we have TANZANIA Online Ordinary Library, right? In this library, we're equipping our students with package of the books, reference books that you need in order to master physics for the Form 4, physics Form 3, physics Form 2, and physics Form 1. One of the reference books that you can have a copy of it, or its original books, is Physics Syllabus for Ordinary Secondary Education, Form 5, Form 1 through Form 4, which is prepared by Tanzania Institute of Education. Okay, and then another reference book. So you can you can order this Physics Form 3 and 4 students' books, which is prepared by Tanzania Institute of Education. So these are reference books. If you have this book, you'll go through Physics Form 3 and Physics Form 4 according to this syllabus. That's why I'm using this book, and I like this book. Okay, again, that is not enough. We like to train our students on how they can solve the nectar questions. which call them certificate secondary education examination questions. So this is ordinary level physics review. So this is another book. So you can order the package, the entire package, or the single book. How can you order this? Because we are selling with a very minimum price. We are not offering free, just like sessions. No, this one we are buying, we are spending money, we are buying. When knowledge, okay, we bought it when we have been studying, but okay, we'll get profit later on, not right now, because God has asked us to offer this gift for the Tanzanians, and gift is for the everybody in the world. Okay, but especially for the Tanzanians. So you can order this package with a very minimum price. Just to go to the descriptions, click the buttons written there, show more below of this video, and then you'll go to the descriptions and you'll see, look the link, mean that the link of Tanzania online ordinary library, and then you can access this book, you can order, and we can send to you in any regions of Tanzania. So right now, I want to use this book as a reference. So the wave is chapter 10 in this book, okay? The wave, okay, waves is chapter 10. So this is the wave, okay? So the goodness of this book, you have descriptions about wave, but at the end of each topic, there are questions which have been called the end of topic questions. These questions, this is what I want to solve some of the questions. I think you see. So, okay, end of topic questions. So remember that physics is universal, whether you are a student from Kenya, from Uganda, from Rwanda, or maybe from Cameroon, from Nigeria. You can enjoy these contents. However, that will be using the syllabus and curriculums of Tanzania, but everything, waves is being studied worldwide. In every continent they study waves. So even if you're a student from America, you can benefit from these contents. So take advantage of enjoying the beauty of physics. So this is one of the books that you can order even. Right now we have a local distribution system. Later on, so we have even continental distribution systems and even international. Keep on praying for us in order to make sure that we impact the life of millions of students, ordinary secondary students of present and future generation. Okay, so example 4 right now. Okay, example 4. So first of all, now we say that we refer the book called the Physics Forms 3 and 4 students books. Okay. Books, okay, student books, the part which is written end of topic question, how to make sure that you have this book, end of topic questions, okay, end of topic questions. So end of topic question, it is in page, these questions are found in page 144 of this book. So we'll be solving some of the problems in order for you to master the wave velocity equation. So this is example 3, and it's a little bit concept, okay, a minor concept. And these questions, okay, yeah. The distance between successful, yes, the distance between successful, the distance between what? Distance between successive. Distance between successful crests of water. Water ripples tank. Experiment is 3.2 centimeter, and the air wave speed is 26 centimeter per second. Determine the wavelengths. frequency, and the period of the ripples, and period of the ripples. That's the question. Read every question carefully. Read it slowly. You can order the package of the books in order to minimize the shipping cost. Okay? Rather than ordering one book in a time. So we advise every student or every parent to order the package of the books because the transport cost will be the same as you order the single book. Okay, so the distance between successful crests of water ripples tank experiment is 3.2 centimeter. And the air wave speed is 26 centimeter per second. Determine the wavelengths, frequency, and periods of the ripples. Wonderful. So solution. These questions should be friends of your solution. Okay? Okay. The first step, just like what you've done in the example 2, the first step, you have to check the data given. Okay, data given. What are we given? The distance between successful cresty of the water ripples tank experiment is 3.2 centimeter. So we'll be given the distance between successful cresties, which I told you how we call it in wave, the distance between successful cresties. We call it wavelengths, but right now let us call D is 3.2 centimeter. Then the air wave speed, so we'll be given again wave speed. So wave speed, which is V, is what? The wave speed is 26 centimeter per second. Again, we'll be given what we have been asked. We have determined wavelengths. This is required. And then we have what? Frequency. This is what? Required. Then we have what? Period, which is T. This is what? Required. Okay, required. So periods of the ripples. Okay, so you go for the second step. Second step, first of all, we have to find wavelengths. Remember, that's a means of recall. Wavelengths, we said, is what? Is the distance. Wavelengths, the distance between two successive crest or trough. For that case, we say that wavelengths is equal to what? Is equal to distance between, this is the abbreviations of between successful crest, which you're being given, which you labeled as D, which you're being given as 3.2 centimeter. So we've already found what the wavelengths. Okay? For the second step, the third step, you have to find what? You'll be given wave speed. You have to find the frequency and period of the ripples. So you have to say we call wave velocity equation or formula. So the wave velocity equation, velocity is equal to wavelength times frequency, right? So you're looking for frequency. So we have divide by wavelengths to both sides. So we are making what? you're making wavelengths the subject. You're making frequency the subject. Because you have to find, because we know the wave speed and we know the wavelengths of the wave. So therefore, velocity of what? Of a wavelength is equal to frequency. And this also, it's the same formula if we write frequency is equal to velocity of a wavelength. So for that case, what is velocity? Velocity being given as what? 26 centimeter per second. For this case, because distance and the means distance, okay, the unit of distance is centimeter and the unit of wave speed is what? Is centimeter per second. So that's why that we should not change. In case you be given that the unity of wave speed is in meter and then the unity of the wavelength is in centimeter, then we have to change centimeter into meter or meter into centimeter. So this is 26 centimeter per second. Be careful in any physics computation. Be careful with SI unit. Be careful with units. Be careful with SI unit. Be careful with other units. Then the wavelength is 3.2 centimeter. So centimeter and centimeter cancel. So for this case, we have 26 over 3.2. Then what? Per second. Per second means that this one, 1 over second. So the frequency is equal to 26. We have to multiply because this is decimal division. So 26 times 10, and here we have 3.2 times 10. But now the unity is per second. That's 1 over second is equal to per second. We taught you the laws of exponent during the formula. So you have 260 over 32 per second, and this will be equal to what? So if you divide, then you get what? So once you divide, you get 8.125. So 8.125 per second. But remember that we told you per second is equal to hertz. Hertz is the name of the physicist who discovered frequency, right? So for that case, you say frequency now is equal to 8.125 hertz. So that the value of 40 of frequency. So frequency, which is F, is equal to 8.125 hertz. Okay, wonderful. So if that the case, then we still have to find another parameter. Another parameter is what? Period of the ripples. That will be what? Which is step? That will make another step. So that will make what? So okay, so I'll be writing question here. So copy this part before I clean it. Pause the video, copy it. I believe you are done. Because I'm using the one reference book. You can refer also some other physics books, if example, that Principle of Physics. We have also About Physics or Physics by Abbott or About Physics in Famous. You may use them. Okay. So this was the third step. So the fourth step, so he said that we call what? We call the formula of what? Of frequency and the period. So we told you that frequency is equal to 1 over period. Or in other words, period is equal to 1 over frequency. So this formula will help us to find out the period. So period is equal to 1 over frequency. So what the frequency? Frequency is 8.125 hertz, or this is 1 over 8.125 and then square 25 per second, because hertz is per second. Right? So period is equal to what? 1. So these derivations of the whole number, the numerator is the whole number, and the denominator is a decimal. So how many decimal points do you have? 3. So you have to multiply the numerator by 1,000 and denominator by 1,000. Okay? And then per second means that this is 1/second. So this will make what? This will make 1,000 in numerator, and then here we have 8,125, and then what? Second. So period of the repose, okay, the repose will be what? Equal to what? 0.20 what? So use 1, 2, 3. 1, 2, 3 second at the period. Okay? So that's the period. So therefore, we can conclude, because the questions asked us determine the wavelength, frequency, and the periods of the repose. So I say that the wavelengths, therefore, the wavelengths, frequency, and the period of the repose is what? First of all, what the wavelength? Wavelength is 3.2 centimeters. What the frequency? Frequency is 8.125 hertz. And what is period? Period is 0.123 seconds, respectively. Okay, wonderful. So this is the response. So the wavelength of frequency and the period of the repose is 3.2 centimeter, 8.125 hertz, and 0.123 second, respectively. Okay. Then let us go to the next example, which is example 4. Example 5. Example 3. Example 1, example 2, example 3. Okay, example 4. So now we are going for example 4. We are referring to the same book. So please copy. So referring the same book. So now we are going for example 4. Same page of the book and of the topic question. And the topic name is wave. So get prepared to copy the next question. So let me back it because this is a little bit long question. So this is example 4, its concept. So that one was question 2. The first one was question 2. So this one in the book is question 8, because end of topic question in the book of physics form 3 and 4 by Tanzania Institute of Education are 8 questions. So this is the last questions. Wonderful. So I'm helping you to solve the last question. So the question states that the commercial program, the commercial program of Radio Tanzania is broadcast on wavelengths wavelengths of 1,500 meter and the 247 meter, the frequency of the 150 meter wave is 200 kilohertz. What is a wave velocity, or what is the velocity of the wave? What is the velocity of the wave? B. What is the frequency of the... In this book they have written 24 meter, but it has been written 24 then space meter wave. So this is typing error because we don't have 24 meter the distance in the previous information. So the distance, the lower frequency means the lower wavelength is 247. So this has been forgotten. So just add it. It's confused because there's a relationship. You see that this is 1500 meter and this is 247 meter, 247 meter. Because we're being asked the corresponding frequency of these wavelengths, because this is lower wavelengths. We expect whenever, so remember that, okay, I think that I have to explain to you something when I'll be solving this problem. Okay, so this is the conceptual questions. It is question number 8. When you'll be mastering to solve questions like this, then you're in good position to be successful in waves. Okay, all right. We'll be solving questions of the past paper in Certificate Secondary Education Examination. It means NECT exams, which has been done in previous year in Tanzania of waves. So stay tuned. We'll be solving so many questions as well as we can in order to make you confident and to be successful. If you want to be an engineer, you have to succeed in that. If you want to be a doctor of medicine, you have to study physics. If you want to be a pharmacist, you have to study physics. If you want to be a chemical engineer, you want to be electronics engineer, just like me, you have to study physics. If you want to be even if that you want to be a technologist, you have to study also physics, but it depends which kind of the technologist, right? And then if you want to be again, if you want to be a dental surgery doctor, then you have to study physics. If you want to be a pilot, if you want to be an aircraft engineer, you have to study physics. So there are so many different places or aspects that you need the knowledge of physics. So you have to enjoy this knowledge. Okay. So solution. Okay, the first stage always of Sir Olenjolai to solve physics questions is what? Or physics or mathematics or chemistry questions. The first stage is data given. What are the data that have been given from the question? The commercial program of Radio Tanzania is broadcasted. Radio Tanzania is TBC, right? TBC, Tanzania Broadcasting Corporations. That's the long terms of TBC. So Radio Tanzania is, okay, the commercial programs of Radio Tanzania is broadcasting on the wavelengths of what? So you see now the importance of wave. If you be a technician at Radio Tanzania, or if you be an engineer who is working at Radio Tanzania, or Radio Free, or Radio Clouds, then you'll be dealing with waves, with signals. You'll be dealing with electromagnetic waves, propagations of the waves. So it means the issue of frequency and the issue of the knowledge of frequency and wave will be applicable in such aspects of life. That's what I told you. I told you we are teaching you how you can take classroom instructions to solve real life problems. So this is maybe a problem that has been composed or problems has been faced by the Radio Tanzania, and then asking some students to find the velocity of the wave of propagations and even to find the frequency of 247 meter wave. So the commercial programs of Radio Tanzania is broadcasting on the wavelengths of 1,000 or 1,500 meter and 247 meter. What are these? These are the wavelengths. So wavelengths, this is longer wavelengths, this is shorter wavelengths. Okay? And then the frequency of 100, I made a mistake here. The frequency of 1,500 meter or 1,500 meter. Okay, meter wave is what? 200 kilohertz. It's 200 kilohertz. What is the velocity of the wave? Remember, the wave will have the same velocity, but frequency will be different. Now, even the velocity, wave velocity. What will be the wave velocity? Right? Wave velocity. So, we say that the data given, first of all, will be given as wavelengths. Right? So we have wavelengths, which is lambda 1. Wavelength 1 is what? It's 1,500 meter. Then you have another wavelength. Another wavelength, which is lambda 2. This is equal to what? 247 meter. Okay? And hence you have the frequency of 40 or 15. So suppose that. Okay? So you have a frequency of 1,500 of 1,500 meter wave. So the frequency, this we can call the frequency what? This we can call the frequency 1. So frequency 1, it's 200 kilohertz. Okay? Then the questions ask us what is A, the velocity of the wave. So A, velocity of wave, which is V, this is required. Okay? Then frequency of 40. Then B, we need frequency corresponding frequency of 247 meter. So 247 meter is wavelength 2. So this also will be frequency 2. This is required. Okay. So then we go for the second step. The second step now, we say that we call the wave velocity equation. The wave velocity equation. The wave velocity equation is what? Velocity is equal to wavelength times what? Frequency. The wave velocity equation. So this is equation 1. So you have to listen carefully. How does this relate? So how do frequency and wavelengths relate? So from this equation, if you divide with frequency, because velocity will be kept constant, so velocity over frequency is equal to wavelengths. So in this case, you find that wavelength is inversely proportional to frequency, or in other words, frequency is inversely proportional to wavelengths. What does it mean? Longer wavelengths, short frequency. You have to bear that, you have to keep that in your mind. Listen carefully. I said, we have velocity is equal to wavelength times frequency. Divided by wavelength, both sides. So this and this will cancel. So velocity is equal to wavelength is equal to frequency. Right? Or in other words, you can say that wavelength is equal to what also? Velocity over frequency. Right? So then you find that frequency is inversely, if velocity is constant, kept constant, frequency is inversely proportional to what? To wavelength. Similarly here, wavelength is inversely proportional to what? To frequency. So you may say wavelength is inversely proportional to frequency or frequency is inversely proportional to wavelength. What does it mean? If you increase the wavelength, you decrease the frequency of the wave. If you decrease the wavelength, you increase the frequency of the wave. So shorter, so remember that shorter wavelengths means shorter, bear this in your mind, my dear student. Shorter wavelengths, right? This always implies high frequency. That's number 1. Then longer wavelengths. Longer wavelengths. This implies what? This implies what? Low frequency. So here we have two frequencies, frequency 1 and frequency 2. This is longer wavelengths. We expect to have low frequency. This is shorter wavelengths compared to this. We expect to have high frequency. Here, low frequency, high frequency. All right? There, that's the concept I want you to understand. Even some questions that will be testing about the relationship between frequency and wavelengths of the wave, then I believe that now you'll kick that such kind of a question. So steady state. We're showing the relationship. Steady state. So the steady state, we have to find first of all velocity of the wave. Okay? So steady state, we say that find velocity of the wave. How do you find velocity of the wave? From what? Velocity is equal to frequency times wavelengths. Right? So velocity is constant for this case. If you change frequency and wavelengths, then velocity of the wave will be the same. Because this is a radio wave. So velocity is equal to what? So for this case, in order to get velocity, you have to take frequency 1, which has been given. Okay, frequency 1, which has been given. Then so you have to multiply with what? Wavelength 1, which has been given. So we know the value of frequency 1 is 200 kilohertz, and we know the value of frequency wavelength 1. So we know the value of frequency 1, 200 kilohertz. We know the value of wavelength 1 is 1,500 meters. Again, I want you to note this. 1 kilohertz is equal to 1,000 hertz. 1,000 hertz. 1 megahertz. This is equal to 1 million hertz, etc. Again, so you have 1 gigahertz. For example, most computers operate in terms of gigahertz. So again, this will be 1 exponent 9 hertz. Then we have 1 terahertz. This you will find in computers. This is 1 exponent 12 hertz. Right? So it means that 200 kilohertz is equal to what? This is equal to 200,000 hertz. You have to change because remember that the wavelength is in meters, not in kilometer. It's not in kilometer, right? If distance is kilometer, then so leave kilohertz at least is logic. So velocity is equal to what? Frequency is what? 200,000, right? Hertz. Multiplied by wavelength, which is what? 1,500 meters, right? So velocity is equal to what? So 15 times 2, it's 30. Then save how many 0? 50. Okay, 50, and then save 20. And then save meter hertz, which is meter per second, right? So that is. So velocity is equal to 300 million. 300 million meter per second. Right? At the velocity. So for Roman A, therefore, velocity is 300 million. Okay, let me write the next part of the blackboard. So A, velocity is velocity of what? Velocity of wave is 300 million meter per second. So that's the response for Roman A. And Roman B we've been asked to find out the frequency of 247 meters. Okay? So we go, B, it is what we have what? The first step. So we say that from velocity is equal to wavelength times frequency. Let us find it. Let us find the frequency. So now we are going to deal with a wave of a new frequency, which is frequency 2. So you are going to have what? Wavelength 2 also. So we have dealt with this and this. So we know the wavelength 2, we don't know the frequency 2. So you have to make it, so this will make it equation 2, or that also is equation 1. So to find, we have to find frequency 2. So we have to divide by wavelength 2, we have to divide by wavelength 2. So frequency 2 is equal to velocity over wavelength 2. Alright. So to find frequency 2, which you expect to be high frequency compared to 200 kilohertz, so the wave speed is what? 300 million meter per second of what? Wavelength 2, which is 247 meters. So meter and meter cancel. So we remain with what? 300 million divided by 247. If you do clear computation, do correct computation, you'll end with what? You end with 1,000. End with 1,000. Okay. We end with 1,214. We rank with 1,214. So 1,214,575 per second, which is corresponding to hertz. So that is what? Frequency. So remember that we say 1 kilohertz is equal to 1,000 hertz. So right now we have 1,214,575 hertz, and this is equal to x. So we cross multiplication. Okay, so in this one we say that this is 1,000, x is equal to what? Is equal to 1,214, okay, 14 what? Then 575. So then about over 1,000, and this one over 1,000 hertz, kilohertz. Okay? So x is equal to what? So x is equal to 1,214.575 kilohertz. You can even convert it into megahertz, right? But that is option. So I think that let us end at frequency 2. Even if you end here, it's 1,214,575 hertz, which is equal to what? 1,214.575 kilohertz. That is. So therefore, this is the answer for Roman B. Take the frequency of frequency of the 247 meter wave is 1,214.575 kilohertz. That's the response. Okay. So again, we say that refer the symbol. refer the book called Physics from 3 and 4 students' books. Okay, student book by TAYAI, Tanzania Institute of Education. So it's ripoti taasisi ya elimu Tanzania. So you have to refer also ending of topic question on page 114 or 144, and then refer question what? So question 6, but we answer only part B. So this will make example 5, which is homework. Homework 4. So let me write. Question has 2 parts, but just deal with part second part. Describe. The question starts with describe an experiment. Describe an experiment to obtain the speed of sound in air. Find the wavelengths. Find the wavelengths of a note. If the speed of sound in air is 3,330 meters per second, and its frequency is 440 Hz. So that's your homework. Describe an experiment to obtain the speed of sound in air. So just leave this. I will teach you in the next session. You have to stay tuned. Remember to subscribe. And then the next part of the question, find the wavelengths of a note if the speed of the sound in air is 330 meters per second and its frequency is 440 Hz. So find out the wavelengths. Very simple question, very simple. No need even to do corrections because it's very simple. Okay, ladies and gentlemen, this is the end of session 4, which has been titled Solving Problems of Solving problems of parameters of waves or dealing with wave velocity equation. I thank God who have created me in his own image and likeness. I thank God who have given me a gift of teaching. I thank God who have given you opportunity to join me in this session 4. And I thank God for you being part of radical changing of the entire nations of Tanzania. And I thank God who have given you an opportunity just to receive this gift, this special gift from Olenjolai to every Tanzanian students of Form 4. Okay? So I thank you very much for receiving it. But again, I have one of an announcement. I have couples of announcement before I end this session. One of the announcement is God has asked me to offer this content free. It's very expensive for you if you want to pay for it. If you want to try, it means that try to access these contents in person. It's very expensive. But God asked me that I am a gifty God told me that Olenjolai, you are a chieftain of Tanzania. So I anointed you with a special way of teaching and with a special gift of teaching. So please teach my students or teach my ordinary secondary education without charging them an amount of money. Why? God has a purpose for the industrializations in Tanzania in just a few years later. But God has opened also doors for you to offer your free willings, thanksgiving from your heart. I'm teaching from my heart. So I have a peace in my mind, I have a peace in my soul, in my flesh, in my heart, that to provide these contents without charging you an amount of money, right? But the doors are open for you if you want to offer your free willing thanksgiving to God through this program. You can do it through two online transactions. Number one is mobile transactions. You may send your offering, thanksgiving offerings through this telephone number 0759 745331. Again, you can send through the bank transaction. Just click these soft buttons written show more. In order to read the descriptions, you'll see the bank account, the bank name, and also the bank, my own account. And I want to tell you in advance, I really thank you for your Thanksgiving offering that you are offering to God through this program. And I want to tell you that every offering that you offer of any amount will be used to pay for the running cost of this program, so that more than 400 videos will be in air and be accessed by any Form 4 student or any Form 3 students or any Form 2 students and any Form 1 students, present and even in future. So the present generations can benefit from this program. So you are planting the seed into the present and future generations in education. And even my kids also will be benefits on these programs as long as we continue to live together. So you can offer your free willings and it will be used for it. There's a very high running cost to prepare one video. We have a vision to prepare more than 400 videos of physics from 1 to Form 4, chemistry from 1 to Form 4, and basic mathematics from 1 to Form 4. So if I want to tell you, or if a certain day I will tell you the cost to prepare one video, and then you will get shocked and you'll get so much surprise because it's very expensive. But that our God is greater than expenses of recording those more than 400 videos. So God is a sponsor of this program. But you can offer your free willing thanksgiving, it will come back to you because you'll be paying so that these programs will be done within the specific time that has been set by the God himself. So remember to subscribe, share these contents. Remember to ask questions in the comment section. Remember just to give us feedback whether you understand what we told you in the comment section. Remember to subscribe once again in order for you to get notification. And remember to have an email and use it effectively in order for you to learn about digital technology. And remember also to pray for me, and I'll pray for you, because really I need the help of God. This is God who is working in me. It's not me. Give God all the glory and praise for this fantastic program. So remember also to visit our Tanzania online ordinary library, so you can access books, scientific calculator, notes, even physics notes for the Form 4, physics notes for Form 3, Form 2, Form 1. You can access them and you can order them, so it's a very minimum cost. So until we meet, I thank you very much for joining me. I invite you to join me in session 5, when I will teach you another concept, and I will teach you about, we'll be focusing on the types of mechanical waves, because I told you that we'll be focused on the types of waves, right? And later on we'll go in details about, to learn about types of mechanical waves, okay? And we'll be dealing with we'll be the transverse waves and the longitudinal waves. So don't worry, get prepared, stay tuned, enjoy the beauty of physics. This is Olenjolai, a teacher and engineer in electronics and telecommunications who loves you so much, and I sacrificed my life for you I sacrificed my safety for you in order for you to be prosperous and successful in life. Until we meet in session 5, stay tuned and enjoy the beauty of physics.